Elon Musk's vision for Mars is not just about sending a few astronauts on a quick trip, but about establishing a permanent, self-sustaining human civilization. He believes that making humanity multi-planetary is crucial for the long-term survival of our species in case of a catastrophic event on Earth. This is an extremely ambitious, multi-decade plan that relies on a series of critical technological advancements and missions. The core technology, Starship. The entire plan hinges on the development of Starship, a fully reusable rocket and spacecraft system. Unlike previous rockets that are discarded after a single use, Starship is designed to be rapidly refuelable and reusable, similar to an airplane. This dramatically lowers the cost of spaceflight, making it affordable to transport the massive amounts of cargo and people needed to build a city on Mars. Starship is made of stainless steel and is powered by Raptor engines, which use liquid methane and liquid oxygen as fuel. This choice is key to the Mars mission because these propellants can be synthesized on Mars itself using a process called in situ resource utilization, ISRU. By using the carbon dioxide in the Martian atmosphere and water ice from below the surface, future colonists can mine their own rocket fuel, allowing for return trips to Earth without needing to bring fuel with them. The phased plan for colonization. The plan to colonize Mars is broken down into a series of logical phases, each building on the success of the last. Phase 1, Uncrewed Cargo Missions. The first Starship missions to Mars will carry no people. Instead, they will be loaded with supplies, machinery, and equipment necessary to build the initial infrastructure. These missions will serve a crucial purpose: to test the atmospheric entry and landing systems, and to begin setting up a propellant production plant. This plant, which will use the Sabatier reaction to create methane and oxygen, is the most vital piece of the early colony, as it enables all future missions. Phase 2, First Human Landings. Once the propellant plant and other key infrastructure, such as power generation and basic habitats, are operational, the first crewed missions will take place. The initial crew will be small, likely around a dozen people. Their main objectives will not be scientific exploration, but to troubleshoot the propellant plant and establish a rudimentary base, which Musk has called Mars Base Alpha. They will begin the work of building a more permanent settlement. Phase 3, Building a self-sufficient city. This is the most ambitious part of the plan. Musk envisions a launch cadence of hundreds, even thousands, of Starship flights during each Mars transfer window, which occurs approximately every 26 months. This will transport the millions of tons of cargo and hundreds of thousands, or even a million, people needed to create a self-sustaining city on Mars. At this point, the colony would no longer rely on resupply missions from Earth and would be able to grow and thrive on its own. Key technological and logistical challenges. While the Starship system is central, there are many other significant challenges that must be overcome to make a Mars colony a reality. Life support. Colonists will need to produce their own food, water, and breathable air. This requires closed-loop life support systems, which are currently being tested on the International Space Station. Technologies like hydroponics or aeroponics would be essential for growing crops. Radiation. Mars has a thin atmosphere and no global magnetic field, leaving the surface exposed to high levels of cosmic radiation. Habitats will likely need to be built underground or have a thick layer of Martian soil on top to provide protection. Infrastructure and materials. Colonists will need to be able to manufacture most of what they need on Mars. This includes building materials, electronics, and medicine. Developing Martian concrete, which uses sulfur as a binding agent, is one potential solution. Health. The gravity on Mars is only 38% of Earth's. The long-term effects of low gravity on the human body are not fully known, but could include bone density loss and vision problems. This would require research and potential countermeasures like artificial gravity or exercise regimens. The economy. For a city to truly be self-sustaining, it needs an economy. Colonists would need to establish new industries for power generation, mining, construction, communication, and more. This project is more than just a space mission. It's a monumental effort to create a new civilization. It pushes the boundaries of engineering, science, and human endurance, with the ultimate goal of ensuring that humanity's future is not limited to a single planet.